Hello everyone. So let's see fifth tutorial, that is case setup. Please note that I'll be using OptiStrat solver here, but even if you are using any other solver, the process would remain the same. So you can see here, I have opened the abstract model file from scratch folder. So in last tutorial, we have seen how to create this meshing related attribute. So now in this tutorial, we'll see the attributes from these three tabs, that is solution strategy, problem definition and output tab. Let's now create some attributes from the solution strategy tab. So generally here we create the attributes which will define what kind of analysis it is, how many subcases are there, and some attribute or some controls related to your solution. So let's see how to create those attributes. So for that, one need to click on this global class. So initially we'll create a subcase attribute. So I'll just click on create and you have to click on subcase. So this way, this subcase attribute editor will get open. So in our case, there would be two subcases. So I just name this as subcase underscore one and I will give ID as 1. So this would be my first subcase. I'll click on apply and close. Similarly, I'll create one more subcase because in my analysis, I want to have two subcases. So again, I'll select on this global class. I'll go in create. I'll again click on subcase. Now this is my second subcase. So I'm just putting name as subcase 2 and I'll put unique ID as 2. I'll click on apply and close. So this way I have created subcases. Now I will create the attribute related to analysis type. So in our case, analysis type would be static. So I'll just create the attribute related to that. So again, click on global class, go in create. In analysis type, I'll just select static analysis. So my analysis type would be static and I'll just give subcase IDs here. So 1, 2. So for both the subcases, the analysis type would be a static analysis. So this way I have created analysis type attribute now. We are done with the attributes from solution strategy tab. Now let's see some attributes from the problem definition tab. So here generally we give information related to material, related to your element types, related to the contact condition, your loading boundary condition. So those details or the attributes related to this physics will come under this problem definition tab. Let's now first create the material attribute. So for that, I'll just click on global class. I'll go here in the create. I'll click on material model, mat1 and this specified. I'll just give name as mat1 underscore steel 1430. So this is my material name. I'll just put details like density, Young's modulus, maybe Poisson's ratio, and then I'll click on apply and close. So this way I have created attribute related to material. Similarly, I will create one more material attribute. I'll click on global class. Again, I'll click on create material model, mat1 and the specified one. So this time I want to create a material attribute for the material steel 2430. So I'll just change mass density to 7.7 e raised to minus 9. I'll put Young modulus as 206,000. I'll put Poisson's ratio as 0.29. I'll click apply and close. So this way I have created two material attributes, one for material steel 1430 and another for material steel 2430. So this way you can create any number of material as per your need. Let's now create attribute related to solid element set. So for that I'll be using child entities. So firstly I'll select still 1430 class. So I'll go in the prune 3D. I'll just select prune 3D of still 1430. I'll click on create. Then I'll go in element, solid and specify. So this is the solid element set for the part having material steel 1430. So I'll just give name as element set steel 1430. So you can give any naming. I'll just select here p solid as a property. Then I'll just select material type here. I'll keep this as set value. I'll just select the earlier created material attribute here. So this way I have created a solid element set attribute for steel 1430 material, or the parts having steel 1430 material. I'll just click on apply and close. So similarly I'll create solid element set attribute for steel 2430 as well. So I'll again go to the child entity, that is prune 3D. I'll select prune 3D of steel 2340. I'll go and create element solid. I'll click on specified. I'll just write element set as steel 2340. I'll just select solid property, that is p solid. I'll just select material type as matte 1, and I will just refer the earlier created material attribute here, and I'll click on apply and close. So this way I have created two solid element set attribute. So one can create it as many as per the need. Let's now create a number of node attribute. So for that I will be using this relation, that is ri steel 1430 steel 2340. So I'll be selecting the child entity, that is prune 2D, and then I'll click on create nodes and number of nodes. So here I'll be putting number of node as 1, and I'll click on apply and close. So this way I have created a number of node attribute. Let's now create a constraint attribute. So for that I'll be using the relation rsolid fixed 2D. So I'll just select this relation, I'll go in create, I'll click on constraint here. So you can see attribute editor will get opened. I'll fill the details here like subcase IDs. So I'll put 1, 2 because for both the subcases I want this constraint. I'll just select 1 to 6 degrees of freedom, and I'll just click on apply close. So this way I have created a constraint attribute. Let's now create a load attribute. So I'll be creating it on the relation load solid. So I'll be using child entity for that, that is a solid side face use. So I'll just select here on the solid, then I'll click on create. I'll go in the load and I'll just select point force. So I'll give name as concentrated load here. Then I'll give some more details like subcase IDs. So I'll put here 2, that is I want concentrated load or the point force to be in the subcase 2. I'll put force magnitude as minus 5000, and I'll just select component 2 here, and I'll just click on apply close. So this way I have created a point force attribute. Let's now create a contact pair attribute. So I'll be giving it on the relation r contact pin contact. So I'll be using child entities. So I want to give it on the side of face corresponding to pin contact class. So I'll just select that here. Then I'll click on create. I'll go in the contact and I'll just select contact pair. So then I'll just give some inputs like contact type. So I'll just select contact type here. I'll keep contact type as a slide and contact orientation as open gap. And I'll just click on apply and close. So this way I have created a contact pair attribute. Let's now create a inertia load attribute, that is a gravity load attribute. So I'll just click on model class, then I'll click on create. I'll go in the loads, I'll just select inertia load and I'll just click on gravity load here. So this will open this attribute editor. Now I'll put the details here. So subcase ID I'll put it as a 1. The load magnitude I'll put it as a 9810. I'll just select component 2. I'll put -1 here and I'll click on apply close. So this way I have created a gravity load attribute. So I'll quickly cover the summary regarding all the attributes from the problem definition tab. So we created material attribute. So it is specified on the global class and these are the material properties relevant to material steel 1430. Similarly, we created another material attribute again on the global class and these are the material properties and the material for this is steel 2430. We created solid element set attribute. It is specified on the prune 3D of steel 1430. So the geometrical entities corresponding to this class will have solid property and will have steel 1430 material. Similarly, in this element set attribute, the geometrical entities belonging to prune 3D of steel 2340 class will have P solid property and material as steel 2430. We have specified number of node attribute on the relation. So geometrical entities corresponding to this relation will have number of node equal to 1. That is, nodes will be merged corresponding to the geometrical entities of this relation. We have specified constraint attribute on R solid fixed 2D relation. So geometrical entities belonging to this relation will have constraint related physics. So we'll be fixing 1 to 6 degrees of freedom and this constraint will be considered in both the subcases. Similarly, we have created a point force attribute. So geometrical entities relevant or corresponding to this relation will have point force related physics. So we'll be applying -5000 load in the y direction and that would be considered in subcase ID 2. So this way we are setting up the physics in CAENexus workflow through attribute and we are using the classes or the relation for that. Similarly, we created a contact pair attribute. So geometrical entities corresponding to this relation will have the contact related physics. So we have set up these properties like contact type and orientation. So that will be considered on those geometrical entities. And lastly, we created a gravity attribute which is on the model class. So it means the gravity load will be applied to full model. The load value would be 9810 in the negative y direction and this loading would be considered in the first subcase. So this way we have covered the physics related to coupling FEA assembly. You can see now we are done with all the attributes from the problem definition tab. Now let's create the attribute from the output tab. In output tab, we generally give attributes related to output. That is what kind of output we are looking for. It's a displacement, stress, strain. So those attributes will come here. So for that, I'll just select model class here. I'll click on create. I'll go in basic output and I'll just select displacement. So this will open the attribute editor. Now I'll just give some more details here like subcase ID. So I'll put 1 comma 2 here. Then the format I'll keep as H3D. I want option as all and I'll just click on apply close. So this way I have created a displacement attribute. Similarly, I'll create a stress attribute here. So I'll again click on model class. I'll go in create. I'll go in basic output. I'll just select stress here. I'll put subcase IDs as 1 comma 2. Then I'll select format as H3D here. Maybe type as one message. Maybe location as corner and option as all. So you can set these parameters based on your requirement. And with this, I'll just click on apply and close. So this way, I have now created a stress output attribute. So you can create any number of output attributes in a similar way. Once done with all the attributes, then I'll just save the abstract model file. And this way, we have set up a case and created an abstract model file for our coupling FEA assembly. So that's all from this tutorial. I thanks everyone, and if you have any queries then please feel free to contact at support@novusnexus.com and we'll get back to you accordingly. So in next tutorial we'll see how to set up a case through simulation author mode. Till that time, have a good day. Bye.